Now we'll discuss about the case 3 of balancing. So case 3 of balancing is balancing of several masses in the same plane. Just like balancing of a fan or blades, balancing of the turbines. So this all comes under balancing of several masses. Several masses are nothing but masses placed in angles, different angles in the same plane, like the fan blades or the turbine or any other blades on a shaft. So we'll see how do we balance such case. So in the figure, as you can see in the figure, so there are 5 different masses. So mass m1 is at theta 1 degrees at radius r1 in the same plane, and mass m2 with r2 radius is at angle of theta 2 from the reference dotted line, horizontal line, and mass 3 is at radius r3 at an angle theta 3, and mass 4 m4 is at radius r4 is at angle theta 4, and the mass m, that is with radius r at theta angle. So now these are different variable masses. So having so all masses are attached to a shaft with constant angular velocity omega radians per second. So in this out of 4 masses, 5 masses, mass m is a disturbing mass, so they have to be balanced. So if the mass m1, m2, m3, 4 are the masses revolving r1, r2, r3, r4 in the same plane, the centrifugal forces exerted on this mass are Fc1 at mass m1, Fc2 at mass m2, Fc3 at mass m3, and Fc4 at mass m4. Let F is the vector sum of these forces, combined force of these forces. So therefore F equals to Fc1, Fc2, Fc3, Fc4. So similarly we can elaborate it as m1 omega square r1 plus m2 omega square r2 plus m3 omega square r3 plus m4 omega square r4. We will take it as equation number 1. The radius is said to be statically balanced. So the vector sum, so it is only, so the system is said to be only balanced and statically balanced if the vector sum F is 0. If the vector sum is not 0, then the vector is unbalanced. Then you have to introduce a counterweight at mass m at radius r to balance the rotor. So now with equation changes to m1 omega square r1, m2 omega square r2, m3 omega square r3, m4 omega square r4, m omega square r equals to 0. Now we will just neglect the omega. We have m1 r1, m2 r2, m3 r3, m4 r4 plus mr equals to 0. Equation 3. So the magnitude of mr can be calculated in generalized form. So in generalized form, you can write the vector sum of m1 r1, m2 r2, m3 r4 as summation of mi ri plus mr equals to 0. That is equation number 4. Now that is the analytical way. Now we can solve. Now so there are 2 ways here. So that's analytical and graphical. So now the analytical way. So first we need to find the vector sum of horizontal or vertical components. So first find the centrifugal force of mass and radius. So first resolve these forces into vertical or horizontal components. Find their sums. How to find the sums? So for horizontal component, it can be written as m1r1 cos theta 1, m2r2 cos theta 2, m3r3 cos theta 3 plus m4r4 cos theta 4. If there are 4 masses, it goes on. Similarly, it goes on for n masses. Similarly, the vertical component can be written as m1r1 sin theta 1, m2r2 sin theta 2, m3r3 sin theta 3, m4r4 sin theta 4 for 4 masses. And similarly, it goes on if there are n masses. Now step 3, determine the magnitude of a resultant centrifugal force R. So the magnitude of resultant centrifugal force R is centrifugal force resulted of MR, summation of MI cos theta I square plus summation of MI sin theta I the whole square. Or in other words, square root of summation of square root of the horizontal component whole square plus the vertical component the whole square. If step 4, the theta, the angle at which the resultant force act, we can find it by tan theta equals to summation of mi ri sin theta I plus mi ri cos theta I. So step 5, the balancing force should be equal to the resultant force and should be opposite direction. Should be exactly opposite direction is this. So 180 plus theta, you should place at the angle 180 plus theta, this theta. And the balancing mass should be R, R equals to, that is resultant R should be equals to M into R. Now graphical way to solve this problem. For the given problem, first draw the space diagram as shown in the figure. So this, the left side is space diagram. So find out the centrifugal forces at rate of mass or rotation. So you have to find the centrifugal forces m1r1, separately calculate m1r1, separately calculate m2r2, so separately calculate m2, m3r3 and m4r4. After calculating this all these 4 centrifugal forces, now we have to draw the vector diagram. So to draw the vector diagram, take a suitable scale. So here first to draw AB with the centrifugal force Fc1 at an angle theta 1, corresponding angle theta 1 for mass m1. So we get, so Fc1 is nothing but m1r1, the value that we get after multiplying m1r1. So after taking a suitable scale, we have to draw the line AB at an angle theta 1. Then from point B, calculate the values of M2R2, so with suitable scale, convert it with suitable scale, and draw B line B to C, that is FC2 or M2R2 value at an angle theta 2 degrees from point B. So from point B, taking horizontal from point B, draw theta 2 degrees at the point C. Now we have reached to the point C. Now for the point C, calculate the value of the centrifugal force value of M3R3. Just multiply M3 into R3. The value that we get, convert into scale, and draw a line C to D at an angle theta 3 from C. So from C, draw a horizontal baseline at angle theta 3, draw FC3, that is C to D. Now again the same thing you have to repeat, that is the draw a line D to E with FC4, that is taking the value of M4 R4, convert it to scale and draw a line at the angle theta 4, that is, so draw horizontal from point D, take an angle of theta 4, draw angle D to E. Now you have reached to a point E. So this with the vector value 1, if it is not closed, then it is unbalanced system. Now to balance this system, we have to connect E and A. So now connect the E and A with a dotted line. So this E and A is nothing but the dotted line E and A is nothing but the resultant R. The resultant R, so measure the line E and AE, the resultant R, and find the angle from A. It's theta. Now this R can resolve into M into R. So this is how we draw the vector diagram. So this was about the case 3. This is balancing of several masses in rotating. Let's see the example of balancing of fan and turbines.